Just kidding. Turns out that's the answer. That's a disgusting answer. Don't know why the book did that. If I write a question, it will not be that. No. So we'll just off to the side here. That's the answer. Yes. All right, let's talk about the weird stuff. Damn, Dr. Horrible. Stuck in my head now. All right. So I'm calling this weird stuff because something weird is going to happen. All right, so looking at this one here, I could, and when it says solve the system, it is literally solve it any which way you want. Since everything's already X's and Y's on one side, numbers on the other, my gut instinct is go with the addition method. Because solving for Y and then substituting in the other is a whole lot of algebra mishmash move around. The addition method, I'm just multiplying by numbers, adding, and then I divide. And 9 times out of 10, you get whole numbers, except for the last stupid one. All right. So if I look at my x's here, I have 3 x's and negative 9 x's. Well, hey, I can turn one of those into the other. If I multiply the top by 3, I'm going to get 9 x's, and then minus 3 y's equals 6. And then I just need to copy this one over. Negative 9 x's plus 3 y's. Oh dear. This is weird. So what happens? 0 plus 0 equals 10? Does 0 plus 0 equal 10? If I asked my daughter that, Lizzie Kate would say, no, in the voice of, God, you're so stupid, Mommy. 0 does not equal 10. So this is a false statement. Now, the reason I write the word false is when you get a false statement, a contradiction like this, because that's the term in the equation that we covered way at the beginning of the semester. So false, negative, no. So remember the two weird things graphically, which was the one that was no. Inconsistent because they're parallel lines. So there is no solution. So if we get a false statement, then that translates to no solution. Now, it doesn't have to be 0 equals 10. It could be 0 equals negative 4. It could even be something, you won't get it from the addition method, but you could from the substitution method get something like 2 equals 3. Doesn't matter, whatever it is, it's something that's false. That means there's no solution. And if you look here, the x's and the y's are the same, just opposite signs. If I solved these equations for y, they'd have the same slope, but different y-intercepts. All right, so we have seen parallel lines algebraically. Now, we are going to solve this system, and that is the answer above it. So the reason I included the answer is because I wanted you to see the way the book wrote it. I'm going to move it down. So when we are going to solve this, so let's start by solving it, see what it's going to look like visually. Well, it's already solved for x, may as well. So we're going to put that in place of the x. So 5 minus 3y's. All right, so this is 10 minus 6y's plus 6y's. Now you see the weird stuff. Those cancel, so we end up with 10 equals 10. And if you're not paying attention or you decided to subtract the 10 over first, you would end up with 0 equals 0. Both of those are true. So when we get a true statement, what it is telling us is that what we thought was 2 equations is really 1. We got the same equation twice. So if I take the bottom equation and solve it for x, I'm going to get the top equation. If I take the top equation, move the y term over and multiply everything by 2, I will get the bottom equation. So that means I've got the same line, which is our double up. So there's an infinite number of solutions, but only the solutions that are on the line. So that is why the answer format looks weird. So let me first write the infinite number of solutions, because that's the first part of the answer. But the second part is we have to qualify that. Well, which set of points? So it's not like all the points where x equals 2. I could have that, but it would look very silly. So here, I just have to take one of those equations and solve it for a variable. Now, the first equation is already solved for x. So if I pick a number for y, any number I want, multiply it by -3 and add 5 to it, I will get the x number that goes with it. So that's why we have this second one here. So it's solved for x, so I put this thing that is equal to x in place of x in my solution for xy. So we have, there's our curly brace to start with, the set of all, this is an ordered pair point, the set of all ordered points with 5 minus 3y, comma y, such that y is any real number. So I pick my y, figure out 5 minus 3y, that point is on the line. Pick another y, figure out the point, that point is also on the line and is also a solution. Now, it looks a little weird using the y. Usually we use the x, that's our independent variable. To do that, though, I have to solve for y. Usually that's our gut instinct anyway. But if I take, like, say, the second equation, let's move the 2x. I'm going to put it in front. So I have 6y is equals -2x plus 10. And then I'm going to divide by 6. I get y equals, this reduces to -1/3 x plus 5/3. And I could write it like that. So that is what y is the same as. So I could say the set of all x -1/3 x plus 5/3 ordered pair points such that x is any real number, or the fancy math way is to say you put a little e for is an element of the reals, the fancy double bar r. Alex won't let you do this, but Alex won't even make you type this in. That will just have you fill in the ordered pair with something like this. Either the x comma this, or it would be the y, the expression in terms of y comma y. So the only part that you actually have to figure out, quote unquote, is either what goes after the x or what comes before the y. Since this is developmental math, if I give you one of these questions, generally, I'm perfectly happy if you stop at infinite number of solutions. If you're going to go on to college algebra, well, really, it's past college algebra, so calculus with what we call parametric equations, that's what this is used for. It can be useful in computer programming because instead of having 2 variables I'm messing around with, I only have 1 here. So that can be useful, or so I'm told. All right. So what is coming up in the next videos, and I will record it as 4 separate videos, is going to be the application question, the word problems, starting with the one I hate, the alcohol problem. Stupid problem. All right. But there's our weird case, the no solution where we got a false statement. And when we get a true statement, it's the infinite number of solutions that we can write in this crazy form. If writing it in this crazy form doesn't make sense, feel free to drop by office hours. We can work through your homework on it till it makes more sense. Because that part of it, it might show up a tiny bit at the end with matrices. Maybe. Probably not.